Hello, welcome to this channel again. In this video I am going to show you how to solve this question. Okay, so this question was also asked in Computational Physics of MSc third semester. Okay, so there are two functions. One is cos x and another one is this one, which is actually the expanded form of this cos x. Okay, 1 minus x square by 2 plus x to power 4 divided by 24 minus x to power 6 divided by 720 in xmgrace or gnuplot. We can use any one of these two plotting tools. Okay, so in this video what I am going to use is let's use xmgrace. It will be easier for you to understand. Okay, and discuss the importance of plotting to approximate any function. Okay, so we will solve this question. Okay, so now let's start the solution. For this, let's open the terminal first by clicking Ctrl Alt and T at once, and then after it opens we don't need to create any file or any other data, so we just use home directory. Okay, so here type xmgrace and press enter, and xmgrace will open like this. This is xmgrace. Okay, so here what we need to do is plot cos x and its expanded form. Okay, so for this, here is a edit option, you can see, and there is a data set, and if we click on data set, the interface opens like this, and here you can go from edit option by formula, or this region, right click on this region, and there is, keep pressing the right click, okay, and go to create new and by formula. Okay, like this, and here we have a default parameter x, t, and we have to give here cos x. Okay, which is $t, cos of $t. Okay, and you need to give the starting and stop point. So starting point would be, let's it be minus 2 pi, and stopping point 2 pi. Okay, and let's give it 1000 points to create. Okay, now if you click apply here, then you will see the plot like this. Okay, so only this much is shown here. So if you click this option, here is ASS, then it will be like this. Okay, this is default plot of cos x created by xmgrace. Okay, we have just provided initial limit and final limit, and there are 100 points, 100 data points created, and it is the plot of $t versus cos of $t. $t means you can say x. Okay, x along $t along x, and cos of $t along y axis. Okay, so this is how you can plot t, cos of t. Okay, here you can name x axis, y axis as well. So if you double click on this axis this line or this line, let me click, the interface will open like this, and you can edit here whether you want to edit x-axis or you want to edit y-axis. Okay, from this option you can change here. Okay, so let me name the x-axis as cos of x. Okay, if you click on apply, it shows like this. Also, let me go to x-axis and type here x. Okay, and it will open like this. Okay, why it is not showing? I think we have to go from here. Okay, this is x. Okay, you can change the limit from here, start and stop, and from here. Okay, and you can change the type of font from here. Okay, Helvetica bold, and apply. Axis changes like this. Similarly for y-axis, Helvetica bold, it changes like this. Okay, and let me close it. For title, just click here. Okay, empty space, just type title here, cos x. Okay, click here. Okay, also you can type here plot of x versus cos x. Okay, it displays like this. And for legends, first of all you have to give the legend name here, subtitle. Okay, for legends just type, double click on this. Okay, and for legend type here cos x. Okay, legend will be displayed like this. Okay, close it. Okay, this much for cos x. We also have to plot for this one. Okay, so let's go to xmgrace again. This xmgrace, similarly go to edit, data set, right click here. Okay, or you can go from edit option, create new, and by formula. And what I have to do is let me keep the limit as it is and just change here. Okay, 1 minus, what is the problem, 1 minus x square by 2. Okay, you have to use some trick to type this. Okay, let me show you how I type it in xmgrace. Okay, type the bracket. Okay, for x means here $t. Okay, type $t in place of x, and there is square divided by 2. Okay, plus, I think plus x4 by 24. Okay, so similarly bracket, inside bracket type $t to power 4 by 24 minus, similarly $t power 6 divided by 720, I think, minus 6 by 720. Okay, like this. Okay, let me create 1000 points or length and apply it. Okay, let me check it is correct. Okay, it is correct. Okay, so if now close it close it. We have two data set here, okay, data file. You can see file, okay. The plot is like this, and it is not actual, okay. This red one is the plot. We have just typed the formula, okay. If you click here as, it shows like this, and obviously this is the actual plot, okay. So to to make it a little bit more clear, you can change the x range and y range, okay. So now x range y range is from 0 to -20, okay. So you can change it, and x range is -6 to +6, okay. You can change the limit and make the plot a bit more clear, more beautiful. And right now let me show you how to add the legend for this red one, okay. Red one means the we have not added the legends, okay, and this black one means cos x, obviously. So to add the legend or the name of this plot, let double click this plot line. It opens like this, and just type here the formula, okay. X, and for each square what we use is capital S square 2 for each square, backward slash n, okay, divided by 2 plus x, okay, power s4 n, okay, divided by 24 minus 6, okay, as power 6 n to close the power first, okay, divided by 700, okay, 720, okay. Now you can, if you after clicking apply, you can see the changes here, okay. Let me click it. It changes like this, okay. Now what you see is the red line is for this formula, okay, and the black one is for this cos x. In this way you can see plot the cos x versus this formula, okay. And don't forget, don't be confused, this is actually the expanded form of this, only up to how much term? 1, 2, 3 and 4 terms. There will be more terms using the even power of x, okay. You can see here, this is power 0, this is power 2 for x, the power 2 4, power 6 and so on, power 8, power 10 and so on, okay. So this is how you can plot the function, okay. Now in second part, what we have to discuss is discuss the importance of function, plotting to approximate any function. To approximate any function, why do we need to plot those functions, okay. So for this I have written here 2 points. Let me show you. So importance of plotting, okay. So why it is important? Because it helps to the plotting the function helps to know the nature of function, okay. As you can see here, nature of the cos x, nature of this expanded form, okay. We could visualize this because of what? Because of the plotting. If we could not plot the function, we could not visualize that the cos x and its expanded form up to 1, 2, 3, 4 terms is like this, okay. We could not visualize it. So the plotting helps us to visualize the nature of the function, okay. And secondly, it shows that the function is continuous or not. It shows whether the function is continuous or not. Similarly here you can see, here the function is continuous actually, okay. There is no breaking point. So this information also given by plotting the function. And you can compare two function as well. Okay, so cos x is the default function and this is expanded form. We can compare these two plots as well, and by comparing this you can explain the nature of these two functions as well. Okay, actually it looks different here. If you change the range, these plots will be somehow very beautiful, look beautiful. So if I do that also, so video will be too long. So I have just given some ideas how to plot it and what is the importance of plotting it. Okay, thank you for watching. We will see you in next video. I will be discussing next question in next video. Okay, so please subscribe the channel and stay connected with us. Thank you so much. This is Smart Learning.